Good morning all. Yesterday we have seen the method for equivalent static methods solving for the evaluation of the design lateral force, that is seismic force acting on a building. So we'll take up the first example today. I'll read out the question, you all can go through. For an RCC, so he mentions the building is RCC, SMRF building, that is special moment resting frame building. For an office, so type of the building is office, the seismic weights on the floors are, weight of the roof is 3000 kilonewton, the weight of the second, third and fourth or the other three floors is 4200 kilonewton. So basically it's a 4-story building. The story heights are, at the ground level it is 4.2 meters, first story is 3.2, second and third story also is 3.2 meters. The building is founded on a hard soil, so the type of soil is mentioned over here, and it is situated in zone 4. So we have to pick the Z value for zone 4. Determine the seismic forces by equivalent lateral force procedure. So maximum of the things that are required for us to solve is mentioned in the question. For example, type of the building, that is SMRF, tells me I have to pick the response reduction factor. It is an RCC frame, and he tells it's an office building, so importance factor is for the office building I have to find. The weights are directly given in this particular example. It's the first example. In some of the examples we have to calculate the weights, and the various story heights are given so that we will be able to calculate at each level the horizontal forces. So let us begin with, from the given data, the R value for RCC SMRF from table 9 page 20, the value of R is going to be 5. So you can refer the code book and you can find the value. It is an office building which is not very important, like 1.5, so I value is picked from table 8 page number 19 to be 1.2. so please go through the table, read the conditions and then follow this. For a zone 4, Z value is 0.24, that is page number 10 table number 3. So we pick up these values. So let us calculate the total height. The first floor or the ground story, he said it is 4.2 and the other three are 3.2. So I simply add them. I have a H value of 13.8. First step, natural period. For given in the question RCMRF building, moment resting frame, I have to calculate the Tn. I have picked up this particular formula from page 9. Tn is 0.075, H raised to 0.75. So I have calculated the H, only H is unknown. Substitute for the H, 13.8, I get 0.5369 seconds. Now based on this Tn, or this Tn is basically used to find the SA by G value, that is the design acceleration coefficient. So SA by G value can be picked from page number 9. I'll just show you. So I have a value of 0.5369. What we do is we go to page number 9 of the code book. Okay, so yeah, this is the for SA by G picking table or the chart. I have to find for hard soil. I know it is a hard soil, and R value of T is 0.53 something. So it lies between 0.4 and 4. So T is this close. So SA by G will be equal to 1 by T. That is what is done in the calculation here. So SA by G is nothing but 1 by T, because I have to follow this particular condition. So on substituting SA by G equal to 1 divided by 0.537, I have the value of SA by G, that is 1.862. Next we have to calculate the EH, that is design horizontal seismic coefficient. Zi by 2R into SA by G. Z.24 based on zone 4, importance factor 1.2, office building, 2 is a constant. Our response reduction factor we found it was 5, into SA by G we calculated from top 1.862. So we have the design horizontal seismic coefficient EH. Now using this we'll have to calculate the base shear. To calculate the base shear, which is given by formula VB is AH into total weight of the building W. So let us first calculate W, which is the total weight of the building. It is 3000 at the roof, and other 3 floors it is 4200. So 3 floors into 4200 plus 3000 gives me the total weight 15600 kilonewtons. Here I have written the explanation for that. Simply substitute in this formula VB equal to AH into W. AH we have calculated, W is this. We get the base shear of 836.16 kilo newtons. Next, we have to find or distribute this particular base shear at each of the levels. So computation of lateral forces at each story. Make up a table. Sorry, the table is missing. Then make up a table where I write first the stories. How many stories are there? Weight of each story, height. Then we know the formula is WIHI the whole square. So what we do? We have a column of WIHI square, and then WIHI square divided by summation of WIHI square, and then the QI. So now we'll come in a reverse order always. 4, 3, 2, 1 like that. So 4 is the roof, 3, 2, 1. 1 being the ground floor. Weight at the roof is 3000. Other 3 are 4200. Then height. The height is always written from the base. So up to the 4th floor, the total height is 13.8. Up to the 3rd floor, I have to deduct now. That is minus 3.2. Second floor, again minus 3.2. First floor, minus 3.2. When you go from base, first ground floor height is 4.2. Add 3.2, 3.2, 3.2. So basically H here in this table, you will be writing it from the base up to the height based on this stories. Then calculate WI into HI square. I have WI, I have HI, this into 13.8 the whole square. So like that I get WI HI square. Square is only to HI, not to the entire term. Then we have individual values. I take a summation of these 4 here, that gives me 13,47,000 odd. So this divided by this gives me this value. For the 3rd floor, this divided by summation gives me this value. Similarly, I get this particular column. To calculate or to distribute it for all the other forces, we know this is the particular formula. So simply substitute, or we have this into the base shear. This into base shear is the formula. So I know the base shear. The value of base shear was 836.16. So 0.424 into 836.16. Similarly, we get all the distributions at each levels like this. I've calculated here. We just put up in the table at this corner. So now to draw the diagram, we have total 4 floors. The ground 1, 2, 3. This is the roof. Ground floor height is 4.2. So Q1, Q2 if I want to show. So at the top it is going to be maximum 4th floor, that is 354. Next 292, 142 and 45. And this is the base shear distribution. So this ends the numerical. The very simple numerical wherein maximum of the things are given, like the weight is given. So it becomes easier for us to calculate. Next few examples we'll take wherein we'll have to calculate the weight when the sizes of the beams or columns are given and the live load is given. So please practice this.